polar coordinates, what are they? Well, polar coordinates, instead of making the plane using x's and y, where they're horizontal and vertical, we get to use something in polar form. Notice it's in the form r theta. So it's some distance away at some direction. Sounds familiar. Should have waited for the bell to ring. Okay, so let's go ahead and see what these means by graph. We can use, again, you can use radians or degrees as it says here. So if we're going to graph the point, where is the point 2 comma 30 degrees? Got a couple different ways of looking at it. If we look at it like an ordered pair, so it's 2 units away. So here's circle 1, so that's 1 unit, 2 units. So it's on the second circle at the direction of 30 degrees right here. So that would be 2 out 30 degrees that direction from the 0, our typical standard placement 0. Okay? Same thing with this one, 4, negative 45. So 4 units out, 1, 2, 3, 4. 2, 3, 4 circles. Where is negative 45 degrees? So that'd be these negative 30, negative 45 would be about here. Now that's one way, and it works pretty good for these. Sometimes different ones, as you will see in 3 and 4, that may throw you. So I look at it a little differently. Instead of thinking 2 out, then 30 degrees, I start on the degree, the direction. If I'm at that direction of 30 degrees, how far away? 1, 2. At the direction of negative 45, how far out? 4. So what that does is down here, then when we have a negative 3, 120, our direction of negative 120 degrees would be here. But instead of being 3 out, it's negative 3. It's the opposite direction. So looking at negative 120, but we're going 3 in the reverse direction, in the opposite direction. So not this way, but behind it. So back here, because of the negative r. So same thing as we look here. Negative 60 degrees, so negative 30, negative 60 degrees is on this direction, this path, negative. So instead of going this with the negative 2, the negative r, we're going in the opposite direction. So it's behind it there 2 units. So negative radius tells you to go backwards. I know we said before negative radii aren't negative, but that's in triangles. This is a specific application to the trig stuff, okay? So that's how we do it. Notice we have 4 different avenues. We could have positive r's, negative r's, positive thetas, negative angles, negative thetas. So we get to name points many, many different ways, and that's what we're going to look at next. How do we name those? Okay, so if we look at this example 5 here, how can we name this in 3 different ways? 3 more ways. Well, right now we have a positive angle, positive r with a positive angle. Well, the negative angle would just be the negative coterminal angle for 135. So that would be 135 minus 360, negative 225. Now, if we want a visual for this, this is, I know this is not going to look good. I'm doing it freehand. So 1, 2, 3, 135 is here. So that's where 3 comma 135 is, 135 degrees. So that would be that angle. Well, the one we just found is going around this way. Notice negative coterminal angle. Now, what about if we change the r instead of positive 3, we go negative 3. Think back to what we did up here. We really didn't graph it at that direction. We didn't graph it on the direction of the angle. We graphed it in the opposite direction. So what angle is down here that's opposite, or instead of at 135, 180, an opposite direction away. Now we like to keep it within one revolution, so plus or minus 360. We don't like to go beyond it in these cases, or 2 pi if we're dealing with radians. So all we're doing for that one is, okay, we'll take our original 135 and add 180. And that is okay. Now, if for some reason, or not for some reason, that could definitely happen, where you start with an angle, when you add 180 to it, it gets too big, it goes beyond one revolution, well then subtract the 180. And that'll happen if you start off with angles in quadrants 3 and 4. So you'd actually be going, well, I'll subtract 180 to go behind it. Then, what about with the negative angle? Well, again, two options for this. We could take what we have here, find the negative coterminal angle. So what is this? Down to the opposite direction from the positive 3. So you could, from here, with the negative coterminal angle, or if you wanted to go here, you're going to do, the change would be, where here we're going to be adding 180, we would subtract 180. So instead of going to the 135 and then, okay, I'm going to rotate that way around to the opposite, we would take it and rotate it around that way, negatively. So 135 minus 180. And that'll take care of that also. Okay. So we're going to be working on that a couple of few days. So keep going with that. So again, different ways of naming it are pretty good. So as we said about rectangular, so instead of thinking about it x's and y's, polar coordinates. So what if we start off with a polar coordinate? 4, negative 120. Or sorry, 4, 120. So if we're thinking about that, I'm going to sort of hide all the circles and say, okay, so we're out here 4 units away at 120 degrees. Hey, wait a minute. That looks like, what's the x? What's the y? Now, that looks like just the magnitude and the direction of a vector. So break it down to component form. That's what we did up here. Instead of thinking of r being the radius, the magnitude, and r acts the same. The direction of the vector would act the same as the angle for that. So this we would just go 4 times the cosine of 120, 4 times the sine of 120. I know that's references 60 and in quadrant 2. So sine of 60, quadrant 2 still positive. So negative 2, 2 square roots of 3. So it's not a different skill. We've been doing that. Instead of the sharp brackets, this is an ordered pair. Okay? Now, how about converting the polar coordinates? How about going the other direction? So 5, 12. Again, I'm going to put a really rough sketch. Here's 5. Here's 12. What's the radius? What's the theta? Component form. So if you would have pictured this as a vector, what's the magnitude? Ta-da! What's the direction? Ta-da! Same old, same old. Okay? Let me get rid of those. There. So r turns out we could read this as 13 Theta would be the inverse tangent of 12/5. So inverse tangent of 12 divided by 5 gives us 67.4. So now we just can't leave it that way. We have to write it as an ordered pair, which is r comma theta. Now how about at 9? So r is just the magnitude. So we could have did that here. We could have just went 5 squared plus 12 squared. But we know that one. Here, 2 squared plus 4 squared, square root of 4 plus 16. Yeah, let's simplify that. Theta. Y is going to be your opposite each time. And then your x is your horizontal because it's to the x-axis. Your adjacent, sorry. And then 63.4. But wait, that's not really theta, is it? That's a good old reference angle. Why? Because what quadrant is that in? So what quadrant 3 angle references 63.4? So 2 square roots of 5, 243.4 degrees. Yes, you can make this to be 4. You could use 4.5, an approximation, because we're approximating the angle, so we're not exact either way. Okay, now we could do the same thing. We use the same thing though. These equations up here, which is what we've seen before, to change the equations from polar to rectangular. Now there are some necessarily tricks because you want to try matching these up. So you got to take a look at it. So if I'm converting from polar to rectangular, I don't, yes, I have r equals this. And that's what I have here. But what about the cosine of theta? Well, let's see here. Cosine of theta, the only other option is up here, but that's r times cosine theta. Right now, that's an issue. We don't have both pieces in there. Oh, but wait. What happens? So let's say if we multiply both sides by r, because we can do it, non-zero number. We know this from up above as x r squared, x squared plus y squared. Now we're going to change that. Instead of leaving it that way, if it doesn't look nice to solve for y, let's make this into the general form. You remember going equal to 0, just like we were doing for the started with the conics kind of thing. So again, it's try to match, try to get your equations to match, to substitute either these or these. That's really the goal. That's really the trick, I guess you want to call it. So 11. Right, nothing with secant. So what's secant? Oh, wait. Multiply both sides by cosine. What do we know that? Again, match from above. Ta-da! That's a vertical line. That's a vertical line at 3. If we would draw that, graph that, we would get that vertical line. Interesting. Same thing with this. Converting the other way. Well, x we know is r cosine theta. Y is r sine theta. Solve for r.